Howdy and welcome back. So we'll go ahead and continue today's discussion by implementing the next element operator, which is going to be the pre-increment operator. We'll go ahead and see its declaration. I've gone ahead and added it to our class definition. So we can see here that operator plus plus, it's prefixed because it has an empty parameter list, and it's going to return, well, basically, as we saw in the doubly linked list, iterator a self-reference. So let's go ahead and begin looking at this. So I've tried to preserve what we've had, or the state we were in after the construction of the object within this kind of example. We said that iter was pointing to the correct first element within the within an in-order traversal at this point. So immediately after construction, if we were to attempt to dereference the iterator, we'd observe the value in 4, which is pretty cool. But now we want to consider, well, how would we move from one node to the next node as it would present in an in-order traversal? Well, we're going to utilize the stack to do that. So when we hit the body of this function, the first thing we're going to check is whether or not the stack is empty. If the stack is empty, we know that we visited every node and there's no more nodes to visit. The traversal is going to be complete. So in that case, if the stack is empty, I'm going to set iter to the null pointer. And the reason being is that that is what is going to define the end of our sequence here. Once we hit null pointer, so in other words, once iter somehow gets assigned null pointer, we can compare that with the iterator that will construct for our binary search trees in function, whose iter will also store the null pointer. And at that point, they'd be equal or pointing to the same thing of nothingness. And then that would imply that, hey, the traversal's complete. But we're not there yet. There's items in the stack. So let's go ahead and walk through this. So the stack in this case is not empty. There's 2 elements within it. First thing we're going to do is set iter to stack's top, and then we're going to remove the element at the top of the stack. So this is going to move iter to this element. And then we're going to remove that element from the stack. So iter now points to 8. And in our traversal so far, we've observed 4 and 8. So we're kind of moving in the right direction here. However, we need to set this up in a manner such that when we increment again, we arrive at the next element in the sequence that would present in an in-order traversal, which is not 20, it's 10. So how do we set this up so the next time we get to this point, we're removing 10 from our stack? Well, to do that, we're going to go ahead and check whether or not the current node has something to its right, because if it does, then it potentially has the node contained within it that would come next in our in-order traversal. So to do this, I'm going to go ahead and create cur, and I'm going to assign it to iter's right. So at this point, cur is pointing here. While cur is not the null pointer, what I'm going to do is push to the stack cur. So at this point, 12 gets pushed to the stack. And I'll go ahead and assign cur to cur's left, which will move cur to that node. Okay, at this point, cur is not yet equal to the null pointer. So what am I going to do? I'm going to go ahead and push that node to the stack. And then I'll go ahead and set cur to cur's left, which is in this case the null pointer. And thereafter, my while condition's no longer satisfied. So we're done and we return a self-reference. So at this point, we've moved the iterator to this element and we've set everything up that's necessary to ensure that the next time we increment the iterator, we will arrive at the next element in our sequence, which here's 10. So if we were to run through this, let's say we plus some binary search tree iterator and it's currently in this state. Well, what are we going to do first? We check whether our stack is empty. In this case, it is not. There's 3 items on it. First thing we then do is we move iter into the address stored at the top of the stack, which, guess what? That is the correct node in this in-order traversal. Thereafter, we go ahead and remove that node from our stack. So 10 is removed. And then we begin that process of setting things up for the next time this operation is called. So what are we checking? Hey, does iters right not equal null pointer? Well, in this case, iters right is the null pointer because that's here. So at this point, we don't even hit into this conditional, and we simply return a self-reference. So at this point, it's pretty cool. We've visited 3 nodes, and we've performed this in-order traversal 2 points so far. What's next within our in-order traversal? Well, that's going to be 12. And guess where it's sitting pretty at? The top of the stack. So if we were to increment things again, we'd hit, the stack would not be empty. There's 2 elements within it. So iter would then be moved to the address of the node stored at the top of our stack. That element would then be removed as so. And then we're going to check to see whether iter has a write. Because if it does, the larger element, the next element within our in-order traversal would be to this node's right? Okay, so we see that it is not equal to the null pointer. So we go ahead and get into our conditional here. And we go ahead and assign cur to iter's right. So cur is not equal to the null pointer. So we'll go ahead and push that address to the top of our stack. Thereafter, we'll set cur to cur's left, which means cur is now the null pointer. And we go ahead and return that self-reference. And guess what? We're set up for the next time. So let me just write what we visited so far. And if we continue this process, we can see how the stack is going to kind of provide us that history to ensure that we get back to where we need to go. And I know this is running a bit long, but I think at this point it's productive to run through this one more time just to see how we get back. You know what, let's just complete it at this point. We're almost there, right? Okay, so let's say we want to move forward from 12. So we go ahead and increment our binary search tree iterator. We end up within the body of this function. The stack is not empty, so we go ahead and move iter to stack's top. Thereafter, we remove that record from our stack. Notice where we're going next. Cool. Okay, so we go ahead and check. Is iter's right not equal to the null pointer? Well, it is the null pointer, so we won't get into that conditional. And at this point, we're done. We've successfully moved to the next slot, and we're all set up for what's to come. Because if there's nothing to the right of this node, we know that the next node in our our in-order traversal is going to have to be kind of the parent to this large subtree. So if we go ahead and we run through this again, so let's say we move forward again, that's going to move iter up, because I shouldn't have drawn all that. Okay, so let's go ahead and say we're moving forward one more time. So, or 2 more to finish up. So iter is going to be set to the address stored at the top of the stack. We can go ahead and remove that activation. Sorry, it's not an activation record because it's not the call stack. Go ahead and remove that element from our stack, the data structure. So we popped it out. Okay. At that point, we need to continue setting things up. So we go ahead and check if iter's right is not equal to the null pointer. Okay, there's something to its right. cur gets pointed to it. Okay, we go ahead and see here, well, cur's not equal to null pointer, cur's not equal to null pointer. Go ahead and push that to our stack, set cur to cur's left, which is the null pointer. So at that point, come back up to evaluate the conditional. Cur is the null pointer. So at this point, we're done. So we've got everything set up for the next increment. And we go ahead and we look here. And yeah, so far we've visited everything in order. The state of iter after each invocation of the plus plus operator was such that iter was pointing to the correct element within our tree. To finish this off, let's say we increment one more time. So in that case, we're going to go ahead, get into this. We see the stack is not empty. There's one element. We go ahead and move iter to that point, to that address, excuse me. We remove the element from the stack. So boom, boom. We go ahead and check, is iter's right not equal to the null pointer? It is the null pointer. So we don't get into the conditional and we return a self-reference. And at that point, the iterator object who invoked this behavior is going to be pointing, its iter data member is going to be pointing to the node with the value 20. And at this point, we've completed our traversal. So if we were to try to increment one more time, we would notice that the stack is empty. So iter would simply then be pointing to the null pointer, which you could go ahead and assume that's there. But the null pointer is kind of the same everywhere. But that's the end of our in order traversal. We've gone through the whole process. So this is, I mean, pretty cool, right? So we've just defined a data type that will allow us to move in order to visit the nodes within this nonlinear data structure. So we start out, at the correct node. Our iterator's iter pointer is pointing to the correct location, or the node with the smallest value upon the iterator's construction. If we go ahead and increment, we move to the correct next element, and this process continues until we visited every single node within our binary search tree. So that's that. I'll go ahead and run through a brief kind of recap of the rest of the operations. Their implementation is rather trivial and are more or less the same to that of the doubly linked list. The major divergence from the iterator that we implemented the other day to that of today is that the construction process of binary search tree iterator objects is very involved. We have to not only kind of find the location, kind of the beginning of our in-order traversal, so walking all the way left, but we also have to preserve that history in the stack so that we have a way to get back to where we're going in kind of a methodical way. And then the next element operation not only had to move iter to the correct next location, but had to set up this stage for what's to come on the subsequent next element operation. So with that, let's go ahead and knock out the rest of today's lesson. I hope this is going good so far, and see you in the next video.